Welcome to the Defense and Aerospace Report. I'm Vago Muradian here at the Association of the United States Army's annual meeting and trade show. Our coverage here is sponsored by AM General, Elbit Systems of America, General Motors Hydrotech, L3 Technologies, and Leonardo DRS. And we're here at Textron Systems, where we're talking to Wayne Prender, who is the Vice President for Controls and Surface Systems here at Textron Systems. Wayne, folks have been talking about case-telescoped ammunition for a long time. I remember I was a young reporter covering the Army, and the guys at GIAT, the French company, were talking about that at the time. A lot of advances have been made. You guys actually have here a 5.56 weapon that will fire that. Talk to us a little bit about what case-telescoped ammunition is, why it's potentially so important for the force of the future, and what are the benefits of what you guys are highlighting right here.
Sure. So fundamentally, case-telescope technology looks to reduce the weight of the ammo as well as increase the lethality of the overall weapon system. So as you know, when our troops are in combat, they're carrying a heavy load. We're trying to reduce that load by going to a plastic polymer case that surrounds a traditional round. That allows them to cut down the weapon system, in the case of a 5.56, by about 20 pounds, 40% weight reduction in overall weapon and combat load. So that's one of the more fundamental reasons that you want to move to a case telescope versus a traditional brass system. We have started development, as you mentioned, years ago, starting with the 5.56. That is a TRL level 7 product right now, shot over 100,000 rounds. Since then, we've also developed the 7.62 variant. That allows us to show that you can expand from a small to a, while still in the small category, a much larger munition. And most recently, and we're pretty excited about this, we've developed an intermediate caliber in this 6.5. So we're showing that the technology not only has matured over time, but we're also able to scale it. We can scale it from 5.6 to 7.62 and anywhere in between.
Walk us through what we're looking at here.
Sure. So we can't get into a lot of the specifics, as you can imagine, but I can show you why or how we take some of the weight out. So if you look at a current round, it's brass with a traditional round and metal casings. What we do with the case telescope is this is now a plastic case, as well as plastic belt. Thank you.
Not at all.
So that allows us to then significantly reduce the weight of the system. In addition to that, because of the way the system is, the system works as a total system of systems, we're able to make other weight reductions to the weapon system. So it's not just that the weapon has lighter materials. In fact, for weight purposes, in comparison, we're using the same barrel so that you can't say, hey, you're using a more advanced lightweight barrel. This, in fact, is for comparable reasons, same barrel between the 5.56 variant and the 249 or the 7.62 variant and the M240. So really what you're getting is reduced weight because of the casings and the associated weight reduced in the complexity of the system and the other design improvements that we've made to the weapon system.
And what are some of the things, the trade-offs that the round allows in the weapon? What changes in the weapon because you're using this ammunition?
So one of the areas that we've had to deal with the plastic ammunition that we've had to address in the design is really the heat. Right, so how do you get heat away from the plastic? So we've taken care of that through a pivoting chamber. So that ensures that the plastic casing is only in the hot part of the chamber, the ballistic part, for a very short period of time. Then it rotates out or moves out of the way. That is one of the key advantages of this weapon system. It has other associated advantages with weight reduction, decreased recoil, so those are some of the things. We also have made advances in the propellant that's inside, and that gives us some advantages on the muzzle velocity and the lethality of the system.
And what are the muzzle velocities comparable when you look at your standard brass-cased shell or the case telescope shell?
We can't get into the specific numbers, but the end state really is lethality at the end of the target. And case telescope, especially with our intermediate caliber configuration, is significantly more lethal at the target at range than a traditional weapon system.
And by that you mean the 6.5 millimeter one that you guys have developed. So essentially what you're saying is that for a 5.56, you would step up to a 6.5, but you would gain the benefits of the heavier round. That's what equalizes sort of the 5.56 extra weight, 6.5 lighter weight, but gets you that same kind of reach and punch.
So 5.56 comparable, M240 to a 5.56 system. You're significantly decreasing weight, and you are getting increased accuracy, reduced recoil, and increased lethality because of some other variables. So there is a one-to-one comparable beyond just weight that makes the case telescope technology more advantageous. Same thing at the 7.62. Those in the industry, to include us and the Army who's done their own caliber study, there is a sweet spot relative to the caliber, an intermediate caliber, the shape of the round, the way it flies through the air, all those things take into account weight and lethality as well. That's what makes our case telescope intermediate caliber really a unique weapon system.
At this point, what are the benefits of continuing to stick with the brass cased technology from your standpoint, right? There's a lot of tradition. We know that it works. We know that it works reliably. What's the challenge to get the Army to step up and to change what they view has been working for a long time?
So I think it's important to recognize that it's not just Textron Systems that is making this case. The Army is making this case as well. So we've developed this in lockstep with the Army for a long period of time. There is a certain point in any technology that you can only make incremental improvements that are not worth the time, money, investment. Weapon systems are really generational. I think it's been stated in the open that the current weapon systems are achieving a point where you can no longer get them to the point that you need to get them. You can make incremental improvements, but you cannot make revolutionary improvements. That's what case telescope offers you, the ability to kind of start from a new baseline, and that baseline then has more runway.
And how much of the Army's weapons, individual weapons, would have to be, there's nothing that will fire the round directly, right? Almost everything has to be modified in order to handle the new round. How much modification would be required for that which is in the Army inventory now to handle the new ammunition?
Yeah, so we're really talking about a new weapon system. So case telescope ammo, case telescope weapon, it really is a system of systems. There is not a retrofit to an existing weapon that'll fire case telescope, because again, there are elements and aspects of case telescope ammo that have to be taken into account in the weapon itself. That being said, there are smart ways to introduce this weapon into the Army's inventory, and we believe that can be accomplished.
And how does it work, right? Because the propellant is on the outside. You know, this is very traditional. You know, you've got your primer, you've got your case with the propellant in it, you've got the bullet that's crimped into the casing, you hit it, primer ignites, propellant ignites, bullet goes. Talk to us about how this setup is working, because the round is effectively nestled in the propellant. Talk to us about how that works.
Sure, and so I think it's important to identify this is not caseless munitions. So caseless, the difference between caseless and case telescope, you mentioned the propellant. And a caseless, that's where the actual case itself would be made up of the propellant. That is not the case here. So the mechanisms that you described in a brass munition are still relevant and still exist in a caseless. So there's still a primer, that primer still ignites the propellant, that propellant still propels the munition out. So really the technology comes into how the round is nestled into the system, and then what sort of plastics and polymers we use to make sure that the system can withstand long-term storage, cold, heat, and the other environmentals, and also is just a robust weapon system. And that's the secret in the sauce.
And so far, is it as robust, temperature insensitive? Does it behave, and can you handle it like a conventional round?
you can't handle it like a conventional round. So the 5.56 rounds in particular have gone through full TRL level 7 testing, where a couple hundred or a couple thousand rounds have gone through various environmentals, so cold, dust, sand, heat, storage, firing. The system is not managed with white lab coats and engineers. The system has been handed off to some of the most practiced military environments, special users, and international as well. So this has been demonstrated and used by international allies, with us there only supporting in a as need basis.
Wayne, thanks very much for joining us. We appreciate it.
All right, thank you.